Hey everybody, it's Brian. Welcome to the 17th. I better double check that. 17th tutorial with Flutter. Got a little frazzled there. My phone was kind of beeping in the background. Anyways, we're going to continue on down our Flutter tutorials and we're going to learn a little bit about I/O. Now, when I say I/O, I don't mean the moon I/O. I mean input output. And the first part of input output we're going to work with is called files and directories. Files and directories is a huge topic, and we're going to kind of condense it down a little bit. So obviously we can't cover every single little use case, but we're going to cover the vast majority of them. We can't cover everything because we will be here for 300 more videos. You can do just about anything with files. You can encrypt them, decrypt them, encode them, decode them, pump them across the network, scramble them up, chop them up, dice them. I mean, whatever you want to do. I hate to sound like an infomercial, but files are quite literally the bread and butter of most programs. So, without further ado, let's go ahead and import Dart convert, Dart IO, and let's work with this. So, the first thing we want to do here is let's say we want to figure out how to list files and directories in a path here. So, we're going to say void list. Help if I actually did that correctly. And we first want to surround this with a try-catch block. Now, why do we want to do a try-catch block first? It's because working with the file system can be very error-prone. If you've ever worked with an older OS or a computer that's kind of flaky, you'll know that really quickly, that sometimes files just do not play nice. All right, so, whoops, equal new. All right, so what we've got here is we've got a directory object, and we're just going to make a new directory object based off the path. Then we're going to say, now if you notice how we can say exists and exists sync. This is kind of the crux of the I/O portion of Dart. I/O is asynchronous. So what they've done is they put some helper functions in here that allow you to help you call this synchronously. So instead of doing exists and then messing around with await and then and futures and all that, we're just going to do these sync and let them do all the heavy lifting for us. So if it exists, then we're going to get file sensitive entity. And we want to list sync. And then we're going to just print out so first thing we want to do here is actually let's get a listing here. So we'll see. We're just going to, I'm on a Linux system, so we're just going to grab the root path. Users, you might want to do that on your C drive. Let's just run this and see what happens here. You can see how we get a whole list of things. This is everything that is on my root path here. If you know Linux, it's really nothing special on this virtual machine. All right, so whoops, I gotta pause the video for 1 second here. Sorry about that. Somebody was at my front door, so I had to go see what it was all about. We're gonna change this path here, and it's just the path that I have the videos in. That way we're working with a very small section of my file system, so if I goof up, I'm not reinstalling my operating system here. Although on Linux it's really hard to actually blow something up. But you can see how we actually have a different structure now, and this is actually the movie that we're creating at this very point in time. So what we want to do is we want to learn how to write to a file. I'm going to say bool, and this is just the way I do it. There's the problem with programming, or I should say the added bonus with programming, is there's literally billions of ways you could do this. I'm just doing it my way. If you don't like it, feel free to do it your way. But this is typically what I do when I'm writing a program. All right, so we're going to do the try catch block. Whoops, we did screw something up here. Now, if you're wondering why I'm doing just a print toString, it's because I want to know when something actually blows up. The last thing you want is what's called a silent error, which means you have a catch and then you don't do anything with it, because then you run your program and nothing happens and you're like, what the heck? So you want to know that there was actually an error, and that's why I just print it out. But all right, so we need to say file. So we're just saying want the file object to be a new file based off the path that we're giving it. And I probably should name this to path, but I'm just going to leave it as file. And then we want to say a random access file. I'm going to call this rf equal new random access file. Actually, nope, sorry, I screwed up. We want to get that off of our file reference. Sorry about that. And we're going to say open sync. Now, you'll notice that there's open read, open, which gives a future, and then open write and open sync. We're just going to work with open sync. There's different types of files. We're going to work with what's called a random access file, meaning we can randomly move around in that file and do whatever we want with it. I typically work with random access files because they're a lot more flexible, although they are a bit slower. Technology's grown to the point that the difference between a random access file and, say, a sequential file is very minimal. And then we want to actually give it a mode. And the mode here is going to be the mode that we give the function, or I'm sorry, the method. If you're wondering what the mode actually means, you can actually say file mode dot and see the different modes. There's append, there's read, there's write, write only, and write only append. Append basically takes an existing file, if it exists. If it doesn't exist, it creates it, but let's just say it exists. And it just keeps adding to the end of it. Think of it like a line in the bank. It'll just keep adding to the end of it. Read will read from the file. Write will completely destroy the file and write it from scratch. Think of writing as, you take your parent a bad report card, they wad it up into a ball, throw it in the trash, and say, bring me another. Write only means you can only write to the file, and write only append is pretty self-explanatory. You can only append to the file. Why they didn't call it append only, I don't know. But all right, so those are the different modes, and that's pretty standard of most operating systems, regardless of what platform you're on. That's kind of like a file primer. You probably spent a week talking about that in your computer science class. All right, so what we want to do now is we want to write string async, and we're going to just say data. And then we want to flush sync, and we want to close sync. So flush and close, those are real keywords. Kind of ignore the little sync at the end here for now. Sync just means that we are asking Dart to do this synchronously. Focus on flush and close. What flush does is think of a file as, well, like a toilet. I hate to say it that way, but think of it like a toilet. And you're just dumping stuff into it. And when you're done, you want to flush that toilet and write it down to the disk. So flush literally tells the operating system, hey, write it down to the disk. Close then closes the file. I am not 100% certain, but I think under the hood, close may call flush for you. I know on some different languages it actually does. I'm not sure if it does in Dart. So I'm going to call the flush intentionally because that is what was out in the actual code they had as an example out here somewhere. I'd have to find it. Yeah, right here. Writing file contents. I think they're doing this because their example is asynchronous and I'm doing it synchronously, so I'm not sure if I actually need to do the flush. I think I just need to close. All right, so now that we know we can write to a file, we need to know how to read from a file. And this is a little bit easier. And we're going to say string, and we're going to say read file. All right, so we're going to just do our try catch block. Now, for some of you, while I'm typing this out, may be reading the comments out on YouTube. There's a lot of folks saying, hey, you know, we don't like these tutorials. We want more Qt or QML, or why are you using Dart and not Qt and QML? It's because I've done a lot of other tutorials in another language called C++ that uses a library, or I should say a bunch of libraries called the Qt. I don't want to call it the Qt framework because it's a Qt library, but it's called Qt. And it is, kind of lost my train of thought here. It runs on any platform. It's an amazing system. I still love Qt, I still love QML, and I want to do more videos on that, but right now Dart and Flutter really have my attention, so that's just kind of my focus. And we're going to say read as string sync. Now, what we're doing here is we're just saying create a new file with the file name, which creates the file object. Now that we have the file object, f in this case, we're saying f read as string sync, meaning that's going to read the contents of that entire file into one giant string and then return a variable. We're then going to take that variable and return it from this method. And what we're doing here is the default encoding, which is UTF-8, which is an entirely different conversation. Encoding is how the actual information is written and read to and from the disk. In this case, we're going to leave it as UTF-8. You can feel free to experiment and change your encoding, but just understand that not all encodings are compatible. So we're just going to leave that as default. All right, so now we have the ability to write and the ability to read. Let's test this out. Let's actually just go here, and we want to say we need to make another variable here. Let's call this txt file, and we're going to just say, just give it a very simple name, and we're going to say if write file, and we need to give it our text file, and we need to say some sort of data that we're going to write to, and we're going to say and then the mode, we're going to say append, and we're just going to play around with this for a little bit. Oops. So really what we're saying, if this, then that. So what's going on under the hood, assuming this works because we haven't actually tested the code, we're going to write to our text file, which is going to be on this path in my virtual machine, and we're going to write this data. This right here is called an escape character, and this right here is called an escape sequence. Wow, I misspelled world. That's embarrassing. So what escape does is it escapes out of the character sequence and says, I want to put a special character in here. /n stands for new return. You can, if you're on a Windows machine, I think it's /n/r or /r/n, something like that. Actually, it's the other way around. I can already tell by looking at it. It's rn, which does a hard return, a new line. That's how Windows does it, but on Linux and Mac, it's just a new line. You can also put like a tab in there. You can put special characters. You can put just anything you want. We're just doing this to break it up so there'll be a line. We're doing that because we're in append mode, and we want a new line every time we run this. Then we're going to print, and we're just reading the contents of the text file back that we just wrote, and we should see hello world down here when we run this. And you see, bang, hello world. So if we go out to our file system, you see that now there is a txt.text, or test.txt, and if we were to open this up, you can see there is hello world in there. Now let's just move this off to the side, run this again, and you see there's 2, now there's 3, now there's 4, and you can see our text file saying, hey, it's changed, we're going to reload it. And that's append mode. It's just going to keep going and going and going. Now we're going to switch this to write mode. Notice how we only have one hello world, and if we go back to our text file, reload it, there's only one. That's the difference between write and append. Append's just going to keep adding to it, where write's going to completely blow it away and start from scratch. I'm going to switch this back to append because I want to put that up on GitHub the way it is. Now, let's say we want to be able to, Let me think about this for just a moment here. Let's say we want to be able to actually pump this out as JSON. So let's do that. Wasn't going to do it, but I'm like, yeah, why not? People are going to ask how to do it. So we're going to say, before we do that, I'm actually going to do something else. List. Sorry for being so scatterbrained. I'm kind of deviating from my original plan here. I'm trying to think in advance of what people are going to ask for. And what they always ask for is, okay, it's great that you can do it in one giant blob, but how do you do it in a bunch of lines? You know, how do you read lines from a file? So I'm just trying to limit the number of questions that I'm going to get off of this thing. And what we can do here is we can just say very simply, and then we can just say readline sync. And you can see how that is currently going to return a list of strings. And it's that easy right there. We could just read the lines. So let's actually do that. And let's comment this out. Actually, let's not. Let's say, see, whenever I deviate from the plan here, things happen very badly, but that's when we probably learn the most. So let's try this txt file. So we want to get the length of this. Let's run that. And you can see how there's 2, there's 3, there's 4, there's 5, there's 6. So there's 6 lines in that list object. So that is how you would read the individual lines. And I'm actually going to comment this. That was embarrassing. Wow, I really just misspelled all of that. So what read lines does is it goes in and it looks for that escape sequence of /n or /r or both, and it actually breaks those up into individual strings. So it's taking that giant string and breaking it down into 6 individual strings. All right, now we're going to go ahead and we're going to read and write some JSON here. So let's actually, all right, let's say bool to, let's say JSON2 file. I'm having a hard time figuring out what I want to call this. There we go. And then we'll say string file. Now, what we're going to do here is a little bit different. What we're going to say is map, and then we want a string and an int. We're just going to basically plagiarize what we did on our last tutorial here. Man, I am getting hungry. Like just sitting here, suddenly my stomach just starts growling. So we're going to put if absence, and we're going to say Brian. But yeah, I've had a couple of people say, what is QML? Why are people getting upset that you're not working on it? That's why I've done like I don't even remember how many. I think like 150, 170 some odd videos. A lot. I've done a lot of those videos, and I've gotten pretty advanced in that realm. So anytime I make something that's not Qt or QML, everybody kind of wonders what the heck's going on. Yeah, I'm going to get back to it eventually. I'm actually hoping to get back to it this winter. All right, so we're going to say string JSON string data equal JSON.encode, and we're going to encode this map, and then we are going to return our write file, and we're going to say the file name, our data, and then our mode. We want this to be file mode.write. Reason being, if we have append, we'll have multiple JSON objects in there, and it'll probably crash the program, or it will just get garbage back, or we won't get the latest object. Something bad will happen. All right, so we've got JSON2 file. Actually, let's call this write JSON. There, that's better. Now I'm happy with it. Now we're going to say void. We're going to read the JSON. I fought JSON for a long, long time. I was really into XML. I did not like JSON when it first came out. XML has just been around forever, but it's horribly inefficient. All right, string data equal, and we want to actually read the file. So we're just reusing the code that we wrote. So rather than reinvent the wheel with the write file and read file, we're just reusing our functions here. Now we need to do a little bit of error handling here. You notice how write JSON is just returning the value of write file. Now with this, we can't do that. So what we need to do is say if data.isEmpty, then we're going to say print no data. And then we're just going to return out of this function. And we should also get the error string from the actual right here, from the actual method. All right, now that we know that we have data, because at this point we should have data, I'm going to say map string int, because this is the structure of our map here. Structure of our map. That really didn't make a whole lot of sense, but I think you guys knew what I meant. All right, so we're going to say people equal JSON.decode, and we're just going to decode that data into an actual object. And then from there, we're going to say print we want to know what the people object contains, just so that we can prove that we actually decoded this. We're going to say people.forEach, and then we're going to say key, comma, value. Let me scroll this down a little bit so you guys can see what's going on. And then we're just going to print these out. All right, so that should work. Let's actually put this down in our main function here. And we need a new file name. So we're going to put this into a different file here. And then we are going to simply say if write JSON, txt JSON, then what we want to do is there we go. So when we run this, assuming it's all going to work, we'll get another, we'll get another file out here. Let me actually go to our directory here. We'll get another file out here called json.txt, and it will contain our JSON object. And then if it returns true in the write, where is it, right here, if that returns true, then write JSON will return true. Then we'll actually read it back, and then we will go through this object and print it out after we've decoded it from string. So this may seem a little complex, but this is actually a really good real-world example. This is really what JSON's designed for, is you would take an object, encode it down to a string, pump it across the network or internet or whatever, and then your consumer, as it's called, the consumer application would take it, read that string, decode it back into an object, and then work with it. And woof,